History of metric system. The meter is an extremely important unit of measurement. It's one of the 7 base units used in the International System of Units, better known as the metric system. Nearly every single country on earth uses the meter to measure distance, unlike Americans, Liberians or Myanmaris. The only 3 countries on earth that still officially use the imperial system. Well, but where did the meter come from? Who decided how long a meter is? How do we know that something is exactly 1 meter? Well, the story of this simple measurement is long, incredibly overcomplicated, and absolutely fascinating. Let's go back to the beginning, to before the meter even existed. This was back in the days when measurement were more of an art than a science, when a foot was the length of someone's foot, whose foot exactly nobody can say, when an inch was the length of your thumb or the king's thumb, or even 3 grains of barley dry and round placed end to end lengthwise. The history of the metric system began during the Age of Enlightenment with measures of length and weight derived from nature, along with their decimal multiples and fraction. The system became the standard of France and Europe within a half a century, and other measures with the unity ratio were added, and the system went on to be adopted across the world. In 1656, Dutch scientist Christian Huygens invented the pendulum clock. With its pendulum marking the seconds, this gave rise to proposal to use its length as a standard unit. He suggested that the new universal measure should be the length of a second pendulum. Essentially, if you make a pendulum that takes exactly 1 second to fully swing in one direction, the length of that pendulum will be 1 meter. Well, sounds like a pretty good idea, After all, that would mean that anyone on earth could make their own second pendulum and know exactly how long a meter is. Perfect! No more grains of barley? Well, not quite yet. Unfortunately, a second pendulum varies depending on where you are in the world. Not a whole lot, but enough that it couldn't be a universal measure. And that brings us back to the drawing board. In 1790, a proposal floated by the French to Britain and the United States to establish a uniform measures of length. A meter based on the period of pendulum with a beat of 1 second was defeated in the British Parliament and the United States Congress. The underlying issue was failure to agree on the latitude for the definition. Since gravitational acceleration and therefore the length of the pendulum varies with latitude, each party wanted a definition according to a major latitude passing through their own country. The direct consequence of the failure was the French unilateral development and deployment of the metric system, and its spread by trade to the continent. Then something happened, and that something was called the French Revolution. France ushered in what it hoped would be a new age of science and knowledge. As such, the French Academy of Science decided it was high time that this whole universal measure thing got settled once and for all. After years of talk, they finally appointed a commission to actually get it done. They were Jean-Charles Desbourda, Joseph Louis Lagrange, Pierre-Simon Laplace, Gaspard Edmond, and Nicolas Descartes. Over the following year, the panel studying various alternatives made a series of recommendations regarding a new system of weight and measure. The proposals were accepted by the French Assembly on 30th March 1791. The panel decided that the new measure of length should be equal to 1/10 million of distance from the North Pole to the equator. Now that was decided, all we had to do was measure the distance from the North Pole to the equator, do some quick calculation, and voila, that is done. Well, not right. Back in late 18th century, measuring such a massive distance was not an easy task. Eventually a plan was made up. Rather than measuring all the way, researchers would simply measure the distance from Dunkirk, France to Barcelona in Spain. Well, these two cities happen to be on the same longitude, so if you knew exactly how far apart they were, you could calculate the distance from the equator to the North Pole. Two astronomers, Pierre McChain and Jean-Baptiste Delambre, were hired to take the measurements. McChain headed down to Barcelona and Delambre up to Dunkirk, and they set about their businesses. But unfortunately, surveying that many miles was still an extremely daunting task. The aforementioned French Revolution ensured that chaos reigned in the countryside. Not exactly the easiest environment in which to do a tedious and precise calculation. The survey was not supposed to take very long, but it ended up lasting nearly 7 years. McChain and Delambre had to deal with the elements and finicky equipments, while also getting thrown into jail and threatened with the death by revolutionaries every so often. But by 1798, after over 6 years of hell, the two of them had a number. Using McChain and Delambre measurement, mathematicians managed to calculate the distance from the equator to the North Pole. They then divided that value by 10 million and finally we had it, the meter, the universal measure. With the magic number finally founded, the Academy of Science had a physical object, a bar made out of platinum, built to the exact dimension. From then on, the bar, known as the meter des archives, was the literal measuring stick for 1 meter. End of story. Well, not even close. First of all, the number that McChain and Delambre had come up with, it was wrong. There were simple mistakes in the calculation which threw everything off. These mistakes would haunt McChain for the rest of his life, and he ended up getting yellow fever and dying while back out in the field, trying to get the calculations right. Now the number was not far off. It was shorter than a true meter by just 0.2 of millimeter. But remember, the whole point of this was to make a meter that was exactly 1/10 millionth of the distance from the North Pole to the equator. Why go through all of that work just to get it wrong? Why, you might as well have skipped all the surveying and just made the meter des archives some arbitrary length and called that a meter. Wait, why didn't that just do that? Well, either way, it was too late now. They have already done the work, might as well keep the meter they would come up with. Regardless of whether it was perfect or not, the platinum meter, henceforth known as the meter, and countries began to adopt this as a standard unit of measurement. The Academy of Science must have felt pretty good about itself, but it was not long until the limitation of the system became obvious. First of all, a physical object, even one made with platinum, will eventually change over with time. Whether through use or decay or whatever mean, this meter will slowly get changed. Ever so slightly, but still it was changing, and the whole point of the meter was that it should never change. Well, furthermore, that single platinum rod couldn't be in more than one place at a time. Other countries bought duplicate, but there was no real way of telling it these copies were exactly of same length or not. Over the years, new, better bars were built in to replace the older one, but eventually it became obvious that we need a better way to define the meter. People tried a different method of defining the meter over the years, but they all had their own shortcoming. In fact, it was more than a century before we invented an ideal solution, that is, the laser. The laser allowed scientists to measure the distance traveling by light particles, and since the speed of light is constant, we finally had a perfect way to define a meter. A way that would never change or vary, and that was replaceable all over the world. That is why the definition of meter used today is the length of the path traveled by the light in the vacuum during a time interval of 1 divided by 299,792,458 of a second. It may sound complicated, but it's still something that tells us it will never get changed. Of course, it does not have the same appealing of grains of barley, but finally you have that a meter with you. I hope you like the content of this episode, and if you like this content and want to watch more of these kind of interesting facts in the upcoming episode, then please subscribe our channel and click the bell icon so that you will be notified whenever we upload the new video. This is Surendra Kaushal from Breaking Code. Have a good day.